All right, let's talk about something that's absolutely critical for anyone building in the cloud: AWS Lambda permissions. Getting this stuff right is the bedrock of building secure and solid serverless apps. So let's dive right in.
When you really boil it all down, Lambda security comes down to these two simple questions. It's all about managing the conversation, right? What can your code do, and who gets to run your code in the first place? The easiest way to wrap your head around this is to think of it like a coin. It's got two sides. On one side, you've got the permissions your function has. That's the outbound stuff. And on the other side, you've got the rules about who can call it. That's the inbound access. You got to lock down both.
So let's tackle that first side of the coin: what your function is actually allowed to go out and do. This is all controlled by a little something called an execution role.
Think of the execution role as your function's official ID badge. When it needs to go talk to another AWS service, it flashes this badge. And this badge says exactly what it's allowed to do. Like, yep, you can read from that DynamoDB table. Or, sure, go ahead and write that file to S3.
And let me be super clear about this. This is not optional. You literally cannot create a Lambda function without one. That's how fundamental the execution role is to the whole security model. It's baked right in from the start.
And at the bare minimum, the absolute floor, every single function needs permission to write logs, so you can see what it's doing. AWS makes this easy with a standard policy, the AWS Lambda Basic Execution Role. Even if your function's job is just to say hello, it still needs this permission to log that message to CloudWatch.
So, how do you make one? Well, in the console, it's pretty simple. You basically just tell IAM, hey, I'm creating a role for the AWS Lambda service to use. Then you attach the permission policies it needs, maybe for DynamoDB or S3, give it a name, and bam, you're done. Now your Lambda can put on that identity whenever it runs.
Now this right here, this is the golden rule. It's so important. The source material really hammers this home: the principle of least privilege. You can start with one of those broad AWS managed policies, sure, but the best practice is to always trim it down so it only has the exact permissions it needs, and nothing more.
Okay, so we've sorted out what our function can do. We've secured its ID badge. Now let's flip that coin over and talk about who gets to knock on the front door. This is where access policies come in.
And we've got two main flavors here. Identity-based policies are for people. You attach them to a user or a group to say, hey, this developer is allowed to call this function. But resource-based policies, those get attached right to the Lambda function itself. They're for giving other services, like S3 or API Gateway, permission to trigger it.
Let's make this real with a classic example. You drop a new photo into an S3 bucket, and you want a Lambda function to automatically fire up and create a thumbnail. Well, for that to happen, S3 needs permission to call your function. And this is exactly how you do it. This policy is attached right to the Lambda. Let's break it down. The principal is the service that's allowed to call, in this case S3. The action is, you guessed it, invoke function. And the condition is the real magic. It locks it down so only events from one specific S3 bucket can do the invoking. S3 is now on the guest list.
All right, let's level up. What happens if you have a really powerful execution role that's shared by a few different functions? How do you stop one function from using credentials it shouldn't be?
This is where a really slick feature comes into play: the lambda.sourceFunctionArn condition key. It's so cool. Basically, when your Lambda's code makes a call to another service, AWS secretly slips the function's unique ID, its ARN, into the request. Then, in our policies, we can check for that specific ID.
So why is this such a big deal? What problem is this actually solving for us in the real world?
It solves what's sometimes called the confused deputy problem. Imagine a powerful role that several functions can use. This key ensures that even if they all share that same powerful ID badge, only the intended function can perform a really sensitive action, like writing to a critical S3 bucket. It prevents other functions from accidentally or maliciously using those permissions.
So check out this policy. This would be inside an execution role. It allows the S3 put object action, right? But look at that condition. It says this action is only allowed if the request is coming from the code of one very specific function, source Lambda. Any other function that tries to use this role for that action, denied. It's an incredibly powerful way to get fine-grained control.
Okay, wow. We have covered a ton of ground. Let's just pause for a second and bring it all together. What are the key things you need to remember?
Here's your security checklist. First, always remember the two-sided coin, what it can do versus who can call it. Second, make least privilege your mantra. Start broad, then trim, trim, trim. Third, use resource-based policies for services and identity-based policies for people. And finally, for those super sensitive operations, use Lambda function ARN to lock those credentials down tight.
So I'll leave you with a little challenge. Go look at one of your own Lambda functions. Is its execution role giving it way more power than it actually needs? I bet it is. What's just one permission you could probably remove right now to make it just a little bit more secure?